Today we're going to be talking about water, or chapter 7. So kind of the interesting thing is we've covered all of these other macronutrients which do provide energy, whereas water, which is also considered a macronutrient, is the only one that doesn't provide energy. But water is very important because it sort of allows for the metabolism of all of those macronutrients and many other functions to happen in the body because of its properties. So we actually need a large amount of water each day. You might have heard the saying that, you can go 2 weeks without food, but only up to like 11 days or so without water. And that's because it is so important to all of our physiologic and metabolic processes. So water is the medium of both intracellular and extracellular fluid. So just think of that, meaning water is literally everywhere in our body. With that, it has a ton of properties and functions as well. It's a general solvent and has a high specific heat. So basically what this means is water is able to help form lots of solutions and help dissolve a lot of things, and it has a high specific heat. So it's able to work in the higher heat of our body. So with the ability to act as that solvent and to perform at a higher heat is super important for all of our bodily processes. Another important feature of water is that it has this dipolar nature. And basically what that means is that we have this two-sided polar feature. So we have a negative end and we have a positive end. What that means is it really is able to attach to a ton of different molecules, which also makes it that good solvent. So if it weren't able to attach to all of those different types of molecules, we wouldn't be able to perform all of those functions within that medium of water. So you've also probably heard that the human body is about 60% water, which is one of the reasons why it is so important that we consume adequate amounts, because we can lose water in several different ways, and we'll get to that. And if we're not adding it back in, we can have a lot of things go wrong. So where do we hold that water? How do we hold that water too? This can depend on our physiology as male and females. It can depend on our body composition, lots of different things. So you may remember adipose or fat and water don't really get along. So keep this in mind whenever we're talking about adipose tissue versus muscle tissue and how much they retain water. If fat doesn't like water, do you think that it's going to hold a lot of water in the fat tissue? No, it's not. On the other hand, our muscle tissue does hold on to more fluid or more water. For this reason, people who have higher adipose tissue compared to people who have a higher muscle tissue and less adipose tissue, they're going to have a lower bodily water content. So think about men versus women. Men typically have a higher muscle mass, whereas women typically have a lower muscle mass and a higher adipose tissue mass. So for that reason, men typically are going to have a higher body water ratio compared to women, and men are going to typically need more fluid or more water per day than women do in most circumstances. So I mentioned, where is this water distributed throughout our body? So you'll see here, most of it's going to be in our intracellular fluid and our interstitial fluid. If you're not 100% sure about what interstitial or extracellular and intracellular means, go back and just find a video and review that. But you'll see that's where most of our bodily water is distributed. And then you see we have some other compartments like our cartilage and our plasma where water does like to hang out in a pretty notable amount. So think our cartilage and connective tissue. These, remember when we talked about hyaluronic acid and chondroitin, like these like to make our joints and connective tissues really plump and cushion-like, and that is because they're able to hold a lot of water. And then our plasma, think of this as our blood. This has a lot to do with our blood volume, so water is important in that. And then otherwise in our bile and cerebral spinal fluid, contents of the lumen and of the GI tract, we'll have a little bit of water, but not nearly as much as these other areas. So one of the most important ways that we can get rid of water is through sweat. All right, so the purpose of sweat is to preserve core temperature and to remove heat from the body. So our body senses that our core temperature is increasing, right? So it reacts by stimulating the hypothalamus to release sweat, right? And whenever we produce sweat, it goes to the surface of our skin and gets wicked away by air, right? And that's what causes the cooling nature of sweating. So this is stimulated by epinephrine and norepinephrine. So think of like your fight or flight response. But just remember, those are the primary roles or functions of sweat. This is just the anatomy of a sweat gland. Not super important that you know, but this is just a little bit helpful for you to understand how sweating actually happens. So another way that we can get rid of water is through excretion through our urine, right? So we talked about in the last chapter how we create urea, and that is going to eventually be dumped into the urine that we form with the kidneys. So overall, our urine is to help us excrete any metabolic waste. Our kidneys, especially the nephron, helps to regulate our fluid, our extracellular fluid in the body, making sure that we're not holding on or retaining too much fluid, and that we're able to create a urine that is perfectly concentrated. So our kidneys can actually develop about 1 to 2 liters of urine per day, and that gives you kind of some insight of how much water in turn we'll need to consume in a day. So this is the nephron unit. I'm sure you've seen this before. You will have to answer some questions on the Chapter 7 questions regarding this. But I want you to pay special attention to your Bowman's capsule, your proximal convoluted tubule, your loop of Henle, and then your distal convoluted tubule. The important things to note and learn here are what is either reabsorbed or filtered in these areas and why that happens. So the purpose of this whole unit is to take away water or take away glucose or put glucose in here or put proteins in here to be dumped in the urine. So there is this check and balance system in place to ensure that we are creating a urine that isn't getting rid of too many things that our body needs to keep, but also can get rid of things that like wastes that our body does need to get rid of. All right, so this kind of explains a little bit more of what I was talking about. So these hormones on these 2 slides here, renin, angiotensinogen, angiotensin 1, and angiotensin 2 are all really important in our fluid and electrolyte balance. So you'll have to answer another question on your Chapter 7 questions regarding these hormones and how they help to control that fluid balance. But just to cover it a little bit, there is this figure, which you can also find in your book. But this is showing you how they are sort of interweaved and related, and how they can help to normalize our fluid and electrolyte balance. So we'll start here. So say we have a low plasma sodium, a low blood pressure, or a low plasma volume, like what we see here. What's going to happen is our kidneys are going to release renin, all right? Renin will travel through the blood towards the liver. Angiotensinogen 2 is going to be converted to angiotensin 1. And then we have the angiotensin converting enzyme that works in the lungs to create angiotensin 2. All right, that's going to go towards our brain. It's going to stimulate the antidiuretic hormone to be released, and then finally we'll reabsorb water. All right, so antidiuretic hormone, this is the opposite of a diuretic. What do we know about diuretics? They are in charge of helping our body make more urine that is, less concentrated. So we have more water and less electrolytes in that urine. We want to get rid of water. So in contrast with our antidiuretic hormone, we want to retain water or reabsorb water. All right, so all of that to say, our body sensed a low blood pressure, a low plasma volume, or a low plasma sodium. The low blood pressure and plasma volume specifically can be caused by less fluid, less volume in general, right? If we have less volume in our blood, our heart's not going to be pumping as hard, our blood pressure is going to decrease, and our plasma volume is decreased as well. So all of this caused water reabsorption in the kidneys, right? All right. These are some more facts about antidiuretic hormone. You'll see in some of your questions how antidiuretic hormone and diabetes insipidus are related. And this has everything to do with those having diabetes insipidus not being able to have, they don't have enough antidiuretic hormone. So they have, they're releasing so much water in their urine all the time. Let's see. So alcohol and caffeine can also inhibit ADH secretion, which means that the urine volume will increase as well. So if you've ever noticed, like if you're drinking a lot of coffee or tea that's caffeinated, a lot of times you'll notice that you have to use the restroom more often. All right. So something else to take a look at that you'll have to answer is the hydration for exercise, because there's special things to consider before, during, and after exercise, depending on how long you're exercising, how intense that exercise is, and then if you've lost weight during the exercise, how much fluid you need to replenish that weight loss. So that's in special feature 7.1 on page 200. You'll have to answer a question about that as well. So we lose a significant amount of body mass daily just not exercising. So that just goes to show you how important it is to rehydrate after you have exercise, especially in intense exercise. One special thing to note is that infants actually lose really significant amount of body weight, and that's just because their body weight already is a lot lower than an adult's body weight. So hydration is important for infants especially. So one thing to note is that not only do we lose water through sweat, urine, and feces, we also release water through our lungs whenever we exhale air. A lot of times we forget about that. Sources of water, of course, the food that we eat, the beverages that we drink, but also, again, we have some metabolic water that's created whenever we breathe, and you can think of that sort of as like condensation. All right, so the range for adequate intake for water can vary greatly, as you can see. Of course, lactating and pregnant women are going to have higher needs than other adult women, but of course, our adult males are going to need much more water because of their body mass differences. One of the interesting things about thirst is that we actually perceive thirst after we're quote-unquote already dehydrated. So thirst can be sensed in a number of ways, but typically is because of a lower extracellular fluid volume. And this is controlled by the hypothalamus.